basically the point of this talk is to show you how you can convert something that people know and something that probably in our heads is connected with the graphic user interface, where you drag and drop image and you click in stuff. You maybe use the recorder to build up a pipeline, and then you run the pipeline. And I always do it with the graphic user interface. But the point is that I would like to do this somewhere up in the cloud in a workflow, and the workflow to me is a synonym of something that runs somewhere maybe on a server where there is no keyboard and no display and actually no one physically sitting in front of that. So I would like to figure out how to, or show you how you can turn this software Fiji into one of these nodes. That's basically the mission. So let's start with a primitive pipeline. You can, you know the story, right? You can start the recorder and clicking around. I open here some images. I trained LabKit, what a surprise, LabKit on the data. And then I used from the MorphoJ, from the Morpho update side, there is a plugin that can, remove the cells that are touching the boundary. And this I will save on the drive. That's the plan. So I will do it in Jython. That's the another language available in Fiji scripting. It's maybe less used, but it's more powerful. And if you're a little bit unsure, I would say ChatGPT is here to help. It's really pretty powerful for this. Now, there's also another feature that's already in a Fiji editor, in a macro editor, is that there's this command completion, which you activate by pressing Control Space. So here's an example. If I wanted to know how to save an image, because one of my mission on this elementary script is that this script is not self-contained. It's assuming that there is already image up there somewhere in the ether of Fiji, and it just takes it and runs LabKit on that. But if this is supposed to be a part of the pipeline, it needs to be explicit data in, then you do the process, and explicit data out where you save them. So I basically, in the first step, want to decorate with some saving, with some opening of a Fiji and of an image and saving it. And you can either use this macro recorder, or this command completion can help you. You just say IJ dot, and then you Control Space, and the menu comes down, and you can try typing in, and then that way you filter, and eventually you find the commands that you might like. So what comes out is the script like this, which is already nice. Not probably everybody knows, but you can run the Fiji, the binary, not only as an icon on a desktop, but double clicking, you can also go to this black terminal and type there. You start the binary itself, and you can say --run, and you point it on the script that you have created. And what it does, in this regime, it will open the graphic user interface again and start immediately executing the script. And this time the script is already reading the data, doing the work, and saving the data. Now, maybe you want to do this script a little bit more smart, because what we didn't like is that the data was already hard-coded in the script. So if you run this repetitively in a workflow, it will be still doing the same thing, still taking the same inputs, still saving the same result. So this is another feature of modern ImageJ, or Fiji, actually Fiji to be precise, is that you can use these decorations. And here is how you can find them, because how should you know what all options you have here? For that we have internet, so no particular link here. Just go to ImageJ.net, that's always the go-to place. Then you say script parameters into the search bar, that's what you're looking for, and then it takes you to a page which already gives you an overview of all options you can have. And so now with this, the Fiji is instructed that it should be yielding, it should be figuring out these three variables, input, output file, and whether it should be using GPU. If you run it in the Fiji in a GUI, it will give out this graphic user thingy where it asks you, and this thing is remembering your inputs there. So next time it comes pre-filled. And I had to modify the script a little bit to basically tell it, take the values from the variables. Now here is already a hint. You can now run this in a headless mode, or if you run it like this without a headless mode, the Fiji will still start. You can provide a couple of parameters, only a subset of them, so it will ask for the remainings. So if you want to have it without any dialog coming out, without anything asking, you have to provide all the parameters yourself. And so this is what it could look like in this story. And with this headless, you make it disconnected from the graphic user interface. So even the Fiji itself doesn't come out. And this is basically the goal of what you want to do. And we could start here, we could stop here. but it's a bit word of warning because it unfortunately doesn't always go that easy. So in this very case, it will actually explode. It will be complaining on the command line. And also Fiji is these days going through a bit of infrastructural changes. You might have noticed that there is a new binary in there with the new starter of Fiji, and this one is not still fully finished with all these, not fully ready for that. So in this very script, I needed to add more of a variables, which are like modern services that are available in Fiji, which helped me to massage data. Problem was that LabKit was not returning the image in the let's say traditional Fiji format. The thing is that you also might have heard that there is ImageJ, ImageJ2, and Fiji. So these are three terms and actually slightly different three pieces of software. And the Fiji community is trying hard to steer the differences away and internally make there like auto magic conversions between these two lands. ImageJ2 is supposed to be more powerful. It has a more powerful data model, and LabKit, being a new tool, is already returning data in this ImageJ2 land. And here, basically, what was happening and what I needed here to solve was that the automatic transition from the ImageJ2 stuff into ImageJ1, because this is what these guys are needing, are in a need. It somehow didn't work out, so I had to explicitly fix it. That's all what it is here. And yeah, so this mixing of plugins between the generations could be a bit of a trouble. And also some of these, especially the older plugins, are tied or connected to the graphic user interface. So they just doesn't work. They don't work without graphic user interface. So this is something that can also bite you. So it's now unfortunately not a free lunch, even though it looked easier from the beginning. But eventually you can make it. And now this is basically, you can stop here. I of course forgot to start the timer. But if you're going now for HPC and so on, good hint is to remove the ImageJ updater, because otherwise every instance that starts will ask the Fiji updates if there is something new. So this is a time saver if you remove this, or you go to Java. I will skip this, how you can go to Java. And finally, I modified the script here. Basically hard-coded here that there are maybe more images, not just the one. This is my original pipeline, but I put it into a one function, and here is the magic. I ask, I'm going to HPC, where there I expect to be a Slurm scheduler. The Slurm scheduler will give me these variables through which my script learns how many Fijis are out there running at the same time, and which Fiji from the crowd I am, this one instance is. And based on that, through this for cycle, it will cherry pick only some images and process them. And the other images will be processed by the other instance. So it's not too many lines that I had to add here. And that's what helped me to make it faster eventually and run it headless on a cluster. Thank you.